Geiger Muller tube. So this Geiger Muller tube, it can be used to detect alpha, beta, and gamma, all three. Okay, alpha, beta, and gamma. Okay, how it work? So inside, this is called the GM tube, the Geiger Muller tube. This part is called a GM tube. Okay, usually, okay, is connected to a scale meter or rate meter, or sometimes it can be connected to a speaker. It can be connected to a speaker, or sometimes even speaker. And sometimes it's connected to the rate meter and speaker at the same time, both also. Okay. Now how it works? This is a GM tube. Okay, Geiger Muller tube. Inside this tube, it contains of some gas. Okay, the helium, neon, or argon gas at low pressure. And then we have a thin mica window to seal the front part of this GM tube, okay, so that the gas cannot go out. Okay, so that the gas cannot go out. Why we use a thin mica window is the reason is this thin mica window can allow gamma, beta, and alpha particles to go inside. If you use paper, then it cannot go in. Okay, so you must use a very thin mica window so that alpha particles can also go in, so that it can detect alpha. If alpha cannot go in, then it cannot detect alpha. And then inside this GM tube, it has two electrodes, positive electrode at the center, and then some negative electrodes at the side. Okay, it's aluminum tube. Aluminum tube. We use the aluminum tube a few mm so that we can block the radioactive from the side. Gamma we cannot block. Okay, gamma we cannot block, but we can block alpha and beta from the side, so that the radioactives come in from the front part here. So we have a positive electrodes and negative electrodes. Okay, and this positive electrode is connected to quite a high power, 450 volt. Sometimes it can be even higher. Okay. Now from here we can see that the negative electrodes and the positive electrode is not connected here, right? So this is an open circuit. Open circuit means that the current cannot flow. No current flow. Open circuit, because the current here cannot go to the current here, or current here cannot go to current. The current here cannot move to this side, and the current here cannot move out also. Okay, so it's an open circuit, no current flow. Okay, but if we have a radioactive source, this radioactive source go inside this GM tube, then it can ionize the gas inside. Okay, because all three, alpha, beta, gamma, has ionizing power. Okay, so it can ionize the gas inside. After it ionizes the gas inside, then the gas molecule contains a lot of positive and negative charged particles. Okay, after ionizing it contains a lot of positive, negative charged particles. The positive charged particles will go to the negative electrodes, and the red one, the negative charged particles, will go to the positive electrodes. And when this happens, it can generate an electric pulse. It's a current, but it's a very short current. Okay, very short current. So it's just a pulse, just electric pulse. Okay, so you see, when this GM tube exposed to radioactive source, okay, every emissions, okay, it emits one times, it will generate a pulse. Emits the second times, it will generate another pulse. Okay, so this pulse is electric flow. Okay, now if this GM tube is connected to a speakers, so every time when there's a pulse, these speakers will produce a sound. Okay, the sound is like okay. So every emission you can hear the sound. Okay, and then you can count. Okay, one time, second time, 4. Okay, so you can count. So you connect it to the speakers, and then you hear how many times it produces sound. Okay, every time there's one emission, it will produce a pulse. The pulse will produce a sound in the speakers. Okay, so sometimes you can hear the sound like okay, means there's a lot of emissions. If you hear the sound like means the emission is very low. Okay, if the emission is too high, okay, you cannot count, like you cannot count, right? Okay, so then we connect it to the scale meter or rate meter, and this scale meter and rate meter, it can count for us. It can count for us. So you just need to read, okay, this one 800 times in 1 minute. Okay, normally it's how many times in one, or this one 2,000 times in 1 minute. You can count 2,000 times in 1 minute, right? So we let the scale meters to count for us. So then that's how it works. Okay, that's how it works. How the GM tube work? So the tube contains argon gas at low pressure. So the end of the tube is sealed by a mica window, thin enough to allow alpha particles to pass into the tube, as well as betas and gamma radiations. And then when the charged particles or gamma radiations enter the tube, okay, it go into the tubes, the argon gas will be ionized. So this trickle a whole valence of ions between the electrodes. So it will produce a pulse of, okay, electric pulse. Okay. So for the brief moments, the gas conducts a pulse of currents flows in the circuit. Okay. Okay, then you know these things, okay, carry radioactive. Okay, what's the functions? First is to detect the presence of radioactive emissions. Okay, for example, you suspect that your room, inside your room, on your table, okay, on your table there are, let's say there's a rock, a piece of rock. You bring it from school. Okay, let's say in your school, okay, you found a piece of stone or rock, okay, it's very beautiful, so you bring it home, okay, and you suspect that these things carry it radiates radioactive. Okay, so how do you know? You can't see, okay, right? Okay, so you must have something to detect, and then you can use this GM tube. Okay, so you point this GM tubes to the rock, okay, and see, okay, there are how many emissions. Okay, if there are 1 or 2 emissions per minute, that's normal. Okay, yeah, because most of the rock emits radioactive, 1 or 2 in 1 minute. Okay, that's normal. Yeah, but if you point your GM tubes to this rock and then you read 200 emissions, that's very high. You can use it to detect radioactive emissions, and you can even count how many emissions in 1 minute. So then you can compare. Okay, maybe you have 2 pieces of rock. Okay, you compare. Point to this one 200 times per minute. Point to this one 300 times per minute. Okay, so you not only detect, you can even count there how many emissions in 1 minute. Okay, so that is the functions of GMT. But you need to know how it works, because in essay questions they may ask you to explain how it works. So the radioactive source ionize the gas. So the negative, so there's a lot of positive and negative charge inside the GM tubes. Positive charge go to the negative electrodes. Negative charge go to the positive electrodes. Okay. So it produces an electric pulse. So this electric pulse sometimes it is connected to amplifier. Okay, it can be connected to amplifier. Connected to amplifier is to increase the currents. To increase the current, so that we can detect the presence of gamma ray. And then we use a scale meter or rate meters to help us to read how many emissions in 1 minute.